All right, so we're going to continue talking about the normal distribution. We have a little bit of a numbering issue here. This is technically the third lesson, but in the book, we're in section 7.2. So let's go ahead and just call this 7.2 continued. There we go, 7.2. This is just more, let's go more normal distribution. And some of the stuff that we're going to be talking about should be familiar. We've done it earlier in the year. And that is the z-score. So if you remember talking about z-score, we're going to kind of review that. Last section when I talked about the normal distribution, I talked about a normal distribution that had a mean of 0 and a standard deviation of 1. That is called the standard normal distribution. Okay, the standard normal curve. So if there is mean 0 right there in the middle, right? Mean always goes in the middle of these distributions, and then the standard deviation is 1, then each of these, if we add the standard deviation, we're now at 1. This would be here at 2, 3, and so on, right? Over here we would have -1, -2, -3, and so on. Okay? So that's the standard normal distribution. The standard deviation is 1. The mean is 0. Now, this is the same as the z-score. So if you remember what z-score was, the z-score, how we used it before is we used it to measure the number of standard deviations away from the mean, right? The number of standard deviations a certain value is away from the mean. So the formula for z-score was z equals x minus x bar over standard deviation. Okay, that's what we used to talk about some sort of sample and how far away is a certain value. We used it to compare distributions. So for example, I think we saw an example where we said, maybe you score an 82 on a stats test. Okay? And that stats test had a mean, so the average score on that stats test, let's say, was a 75. And the standard deviation of that stats test was, let's say, 6. Okay? And then we use z-score to then compare that to, let's say, another completely different test. So say you scored a 94 on a history test. Okay, and the mean of that test, so the average score of that test was, let's say, 90, and it had a standard deviation of 3. Okay? And so the question we used z-score for previously was, well, which one did you do better on relative to the mean, right? Because obviously, if we see 94 versus 82, we think, okay, 94 is a lot better. But if we were to standardize both of the tests so that they are essentially turned into a standard normal curve, then we can compare them with each other, even though they have different means and different standard deviations. So let's go ahead and just recap how we did this. We would do the first situation, the stats test, the z-score would be 82 minus 75 divided by 6. And then this history z-score would be 94 minus 90 divided by 3. Okay, so, what does this come out to be? This z-score is, looks like 7 over 6, whatever 7 divided by 6 is, and this one is whatever 4 divided by 3 is. Okay, so now if we compare those, okay, so 7 divided by 6 and 4 divided by 3. And so what we would get, our result would be that on the stats test, you scored 1.17, approximately 1.17 standard deviations above the mean, because that's positive, right? And on the history test, you scored 1.33 standard deviations above the mean. And so relative to the mean, you did better on the history test, okay? That's how we used standard z-score before, okay? Very similar to how we're going to use it now. I mean, there's really no difference. It's just that now we can see how it's relating to all of the different distributions. So now we can take any distribution and sort of normalize it and compare it to other distributions and so on. So the book goes on to talk about pretty much what I was talking about, right? The number of standard deviations above or below, or how to relate it to the curve. It also talks about how to find area under the curve. Now, we already talked about that briefly with the calculator use. We're going to continue working with the calculator. We're not going to look up these tables like they have here. And again, it's important to remember that the area under the curve is the probability. And really the next thing what we want to talk about is percentiles. So, percentiles. So what do we remember about a percentile? Percentile is, if I say that, a baby is born in the 83rd percentile of weight, what that's saying is that that baby weighs more than 83% of all other babies. Okay, so percentile is the percent a data value is greater than. Essentially, that's kind of a simple way to put it, right? So if you're in the 99th percentile of GPA, then your GPA is better than 99% of all other GPAs, right? That's kind of where you want to be. That's percentile. So with that said, how is that going to relate to this normal distribution? Well, if we're finding probabilities, we're essentially finding percentages, right? So if I have, let's say I have, whoops, that was, well, anyways. Let's say I have a standard distribution with mu equals, let's say 50, and a standard deviation of 8. Okay? And I want to know what percentile is a value of, let's say, 60. Well, essentially what I'm doing is I'm finding where 60 would be, okay? Approximately where 60 would be. And I want to know what percent is less than 60, because that's what percentile is, right? And that's just what we've done on the calculator already. So I'm trying to find this whole area, right? All the way to the left. Now, as we go further and further away from the mean, the probability of that occurring, like if I took this distribution and asked what's the probability of having less than 2, if the average is 50 and the standard deviation is 8, what's the probability of being less than 2? It's essentially 0 because it's so far away from the average. So this curve technically continues forever, but it gets so small that it really doesn't matter. The reason I'm talking about that is because when we go to our calculators and we're going to go into second distribution and we're going to go to the normal CDF, and the lower and upper bounds, right? I'm not looking between two values. I'm just saying what's less than 60. It defaults to -1 times 10 to the 99, which is a huge negative number, right? If that's there, great. I don't necessarily need to use that. But what I do use is I just put in -99999. I just type in a bunch of 9s, right? Because that is going to represent this all the way over here, right? All the way to the left. So I'm going from 60, which is going to be my upper bound. So I'm going to type that into my upper bound. And I want everything to the left. So I'm going to go all the way to the -9999999, right? So I'm going to make this huge negative number, and that will be sufficient to sort of stand in place of like negative infinity, right? Because obviously we can't type in negative infinity, but it's far enough away from 50, right, that that'll work. Okay, now we don't have to really use z-scores here because the calculator, we can put in our own parameters, our own mean of 50 and our own standard deviation of 8. So some of the book has to do with converting to z-scores, but we already did that work, so let's just go ahead and use the parameters we're given. So now if I calculate this, it's going to give me the area. So approximately 89.4, right? So percent. So this area that I got here, the area was 0.894 approximately. That's a point. Okay. And so what percentile of values of is a value of 60? Approximately the 89th percentile, right? Percentile, we don't really go into decimals really. So we could say approximately the 89th percentile. Right? So if we were talking about some sort of test where the average was 50 points and standard deviation was 8 and you had 60 points, what percentile rank would that be? It would be the 89th percentile. This is also another way of giving a true curve on an exam, right? A true curve on an exam doesn't necessarily help everyone. It sometimes hurts people because it standardizes it down to a normal curve. So if this was the exam where the average was 50 points and the standard deviation was 8 points and you had 60 points and we curved it for a true curve, you would be given probably like an 89% on that test, right? And you can kind of see how that might hurt a lot of people as well, because the people on this side end up getting a much lower score. So anyways, So that's, again, that's percentile, right? So the percentile is kind of equal to the area under the curve, because the area under the curve is percentage, probability, percentile. Okay, good. So let's do a quick example. Which one do we want to do here? Well, no, I just did an example. That's fine. Let's move on. Let's move on. So now what we want to talk about is going in the other direction. So suppose, let's bring this back. So let's do another example here. Suppose we have a normal distribution with a mean of, let's just make up some numbers, 78, standard deviation of 5, and we want to know, let's say we want to know, well, what do I need? Let's say this, again, let's say this is a test, right? So the average was a 78 and the standard deviation is 5. The question is, what would I need to score in order to be, let's say, the 90th percentile? So what score is the 90th percentile? So again, I always like to draw these. So I just quickly sketch a curve. I know that 78 is right in the middle. And I know my standard deviation is 5. And I'm looking for the 90th percentile. So I know that 90% of the data it's going to be somewhere over here, right? So I'm looking for this value, where this whole area, right, this whole shaded area is 0.9, right, because that's the 90th percentile. So now I'm actually given the area and I'm trying to find a score. To do that, what we're going to do is we're going to go back to our calculators and we're going to again go back to the distributions, so second vars, the distributions, and this time we're going to do the inverse norm because we're kind of working backwards, right? So we have the percentage, we need to find the score. So the area, and when you go into inverse norm, you might not see this tail part. So I'm always going to leave it, I'm not going to mess with that one at all because you guys might not have that. Know that on calculators it will always default to the left side, so the area to the left. So the area to the left, back here, the area to the left of what I'm looking for is 0.9. So I'm going to type that in, 0.9, and I'm going to put in the parameters. So it's an average of 78 and a standard deviation 5, and I'm just going to calculate that. So that tells me I need about an 84.4 to be in the 90th percentile, right? And so this would be 84.4 if that value was x, right? So that's working backwards. That's finding a score given a percentage or given a percentile, okay? And that's going to be really with that plus normal CDF, that is the normal distribution. That's like the main stuff we use. So just remember that if it's talking about a standard normal curve, that's telling you what the mean and standard deviation should be. It's telling you that the mean and standard deviation should be a mean of 0 and a standard deviation of 1. Okay? So that's standard normal if they talk about standard normal, or if they talk about the z distribution, right? That's what they're talking about there. If they're talking about any other parameters, we can just use our calculator to plug in those parameters. Okay, we can plug in the 50 and the 8, whatever we need to do. All right? So really not much more to talk about in this section. I do just kind of want to go over maybe a couple of the problems that you guys will be doing. So let's take a look at some of these. So like here, if they're talking about the normal curve, oops, let me get that out of the way. So if they're talking about the normal curve there, remember that's mu equals 0, sigma equals 1. Let's take a look at, how about 24? Okay, you can't see it. There it is, 24. So in problems 23 through 32, assume the random variable is normally distributed with a mean of 50, standard deviation of 7, and we're going to find the probability that x is greater than 65. So this is number 24. We have a curve. We have a mu of 50, sigma of 7, and we are finding the probability that x is greater than 65. Okay, so 65 is going to be somewhere over here maybe, right? I'm just going to approximate that. And I'm looking for this area. I'm looking for the area to the right. So with normal CDF, I can just do this based on the bounds, right? Lower bound is the left side of the shaded area, and upper bound is the right side of the shaded area. So if I go to my calculator, and let's go back to the distributions, I'm going to do normal CDF. I'm doing normal CDF because I'm finding a probability, right? If I'm finding a probability, I'm always doing normal CDF. The lower bound of this shaded area is 65. The upper bound of this, well, that's going to be going all the way to the right, going off to positive infinity. And so for that, I'm going to use a positive 9999999, right? Just a bunch of 9s. Mu is 50, sigma is 7. I'm just going to plug that in, and there's my probability. So a 0.016, right? And I can leave that as a decimal. I can write it as 1.6%. It doesn't really matter. Okay, what does matter is if we're using inverse norm, we have to use the decimal, right? So if I were to, if I wanted to do this in the other direction, right, I would be looking at, so this is good to talk about. So right now I have this area right here is equal to 0.16. So if I wanted to find this value of 65 again, like if I didn't know what 65 was, I was given the mu of 50, the sigma of 7, and this area to the right being 0.016, I would be using, sorry. I didn't have the calculator open for that, whoops. Well, anyways, that's what we did. We typed in 65 as a lower, upper 9999, and so on. And that's how we got our answer, okay? So now I'm gonna go back to inverse norm. And the area, because the calculator will always be talking about the area to the left, I now have to think about what is this area over here. So if this is 0.016, then do 1 minus 0.016 to get the area over here, which would be 984. Okay? So now we plug in the area, and we have to keep it as a decimal. We can't put in 98.4. We have to put 0.984, 50, 7, and we hit enter. And there's, because we rounded that value, right, there's that approximate value of 65. Okay, so that shows both directions there. So I think that's going to be it for this section. You guys will do some of these problems, and I will see you for the next one. All right.